You know, the technology that controls our physical world, from the power grid to our water supply, it's facing a totally new kind of threat. So to fight it, we're turning to a new kind of artificial intelligence. Today, we're going to dive into the AI that's been designed to protect the very infrastructure we all depend on every single day.
All right, so first up, we're going to uncover a critical security blind spot that has quietly put all of our infrastructure at risk. Then we'll meet the digital workforce that's been built to fix it. We're even going to peek inside the system to see how it thinks. And finally, we'll explore a massive strategic shift, moving from just hoping we're safe to actually knowing we are.
Okay, so what is this critical blind spot really? Well, for decades, the systems running our physical world, I'm talking factories, power plants, you name it, they were thought to be untouchable. Why? Because they were isolated. But one huge fundamental change has just completely wiped out that safety net.
So on the left, you've got the old air-gapped world. Think of this as back in the day. That operational technology, or OT, that's the stuff controlling the heavy machinery, it was totally walled off from the internet. It was secure because, well, you couldn't get to it. But now, look to the right. That's our world today. For the sake of efficiency, we've gone and connected everything, our regular IT networks and that OT stuff. And in the process, we've basically created one giant, juicy target for attackers. And just like that, poof, the gap is gone. That protective bubble, it's completely shattered. And honestly, this one change is the root cause of the entire security crisis we're now facing when it comes to our physical infrastructure.
And let me tell you, the stakes here are just terrifyingly high. I mean, think about it. A normal IT hack, okay, maybe they steal some data. Bad, but manageable. But an OT breach? Now we're talking about a city's power grid going dark, a water supply getting contaminated, a whole factory just grinding to a halt. This isn't about data loss anymore. It's about real-world physical catastrophe.
So you might be asking, well, why can't we just use the old security tools? The simple answer is they were never, ever built for this new reality. Manual testing, it's sporadic. It gives you a tiny snapshot in time that's basically useless a minute later. It can't possibly cover these gigantic networks, which leaves massive blind spots. And on top of all that, it's crazy expensive. The bottom line is, the old way just can't keep up. We need something totally new, something that's continuous, that's comprehensive, and that's actually efficient.
All right, so if human teams can't possibly scale up to defend this new, massive landscape, what's the answer? Well, it turns out the solution has to be something different. Enter a new kind of digital workforce, the multi-agent system.
So what in the world is a multi-agent system? Instead of thinking about a single piece of software, I want you to picture a whole team of autonomous, intelligent software agents. Each one has its own specialty, and they all work together to solve these incredibly complex security problems. Problems that would be way too big for any single agent, or honestly, even a single human to handle alone. And let's be super clear here, we are not talking about simple automation. This is more like having a digital team of elite experts. These software agents have memory, so they can learn. They can reason their way through really tricky problems. And crucially, they collaborate to connect all the dots. But here's the kicker. They actually understand the real-world context of the systems they're protecting. And that right there is the key. This isn't about just finding random bits of data like an open port somewhere. It's about understanding what that data means. It's about connecting the digital dots to the physical consequences. Let me give you a perfect example. A normal dumb scanner might just report back, hey, port 502 is open. Okay, so what? This system, on the other hand, understands that an open port 502 on a very specific Siemens PLC, well, that's a direct highway for an attacker to get in, mess with its programming, and cause actual physical damage. See the difference? One is just data. The other, that's intelligence. Okay, so you're probably thinking, giving that much power and autonomy to an AI system, that sounds a little scary. And you're right. It requires a ton of trust. So let's pull back the curtain and see how this thing is actually designed to be incredibly precise and reliable. So how do you keep this digital workforce from just running wild? Well, it's not some chaotic swarm of bots. It's all organized using what's called a hub-and-spoke model. There's a central root agent that basically acts like the conductor of an orchestra. It coordinates all the other specialized agents, making sure every single action is deliberate, controlled, and part of the plan.
And these actions are anything but random. This system follows a super structured, multi-phase workflow from the very beginning to the very end. What's really cool is that this whole process was designed to perfectly mimic the methodology of the world's most elite human security teams. It's disciplined, it's meticulous, and it makes sure every step builds on the last one. Trust isn't an afterthought here. It's literally engineered right into the core of the system. It has this robust memory, so it's not starting from scratch every time. It learns and remembers context. But this next part is crucial. It has an internal refinement loop. You can think of this like an automatic peer review process. The system literally double-checks its own work, refines what it finds, and catches its own mistakes before a human ever sees the final report. This builds in a level of reliability that's just unprecedented.
Okay, so let's zoom out and bring this all together. What does this kind of technology actually mean for the bigger picture? Well, it's not just an upgrade. It represents a fundamental shift in how we protect our physical world.
You know, if you had to boil down the current state of security for so much of our critical infrastructure into one word, it would be hope. We're using outdated, infrequent security checks against threats that are constant and evolving. So a lot of organizations are basically just crossing their fingers and hoping they're not the next headline. And hope, as we know, is not a strategy. This really lays out the two paths we can take. On the left, you've got hope. It's like trying to cross a canyon on a rickety old rope bridge. It's a reactive strategy that's always just one bad day away from a total disaster. But on the right, you have verified resilience. This is a proactive strategy. It's built on continuous, intelligent, automated assurance. The whole goal shifts from hoping you're secure to constantly verifying that you are. It's a total game changer. And all of this leaves us with one final, really important question. As our physical and digital worlds continue to slam together, is this kind of intelligent automation just another cool innovation? Or is it now a fundamental necessity for protecting the very foundations of modern life?